Imagine a giant cloud of gas and dust swirling in the vastness of space like a cosmic dance of particles. This cloud, called a nebula, was the birthplace of our solar system, a stellar nursery where stars and planets are born. Over millions of years, gravity pulled this dust and gas together, creating a gravitational ballet that drew material inward. The center became incredibly hot and dense, eventually igniting to form our sun, a blazing beacon in the darkness of space. Around this newborn sun, leftover material continued to spin, forming a protoplanetary disk. Particles collided and clumped together, gradually growing larger like cosmic snowballs gathering more material. These clumps became planetesimals, the building blocks of planets, each collision adding to their mass. Earth, like the other planets, formed through this process of accretion, slowly taking shape in the protoplanetary disk. As planetesimals crashed into each other, immense heat was generated, melting and reshaping the young Earth. The young Earth was a fiery ball of molten rock, constantly bombarded by debris, a chaotic and violent beginning. Over time, the bombardment slowed, allowing the Earth to begin a new phase of its evolution. The Earth began to cool, its surface hardening into a primitive crust, a solid foundation for future development. This marked the end of Earth's initial formation, but it was only the beginning of an incredible journey. A journey that would eventually lead to the emergence of life and the world we know today. The early Earth was a place of intense volcanic activity, a world where the ground trembled and the skies were filled with ash and smoke. Molten rock from the planet's interior erupted onto the surface, spewing lava and releasing gases into the atmosphere. These eruptions were not just occasional events, but a constant and defining feature of the young planet. The air was thick with carbon dioxide, nitrogen, and water vapor, creating a dense and suffocating atmosphere. This mixture of gases was crucial in setting the stage for future climatic and biological developments. The constant volcanic eruptions played a crucial role in shaping the Earth's atmosphere and surface. Each eruption contributed to the formation of the planet's crust and the release of essential gases. They released gases that would eventually form our oceans and contribute to the development of life. The water vapor released by these eruptions began to cool and condense, leading to the formation of the first bodies of water. As the Earth continued to cool, the water vapor in the atmosphere condensed. This process was slow and gradual, taking millions of years to create the conditions necessary for liquid water to persist on the surface. Rain fell upon the hot surface only to evaporate immediately back into the sky. This relentless cycle of rain and evaporation was a key part of the planet's early climate system. This cycle of precipitation and evaporation continued for millennia, gradually cooling the planet and allowing for more stable conditions to develop. The surface of the young Earth was a dynamic and inhospitable place, constantly reshaped by volcanic activity and meteorite impacts. Volcanoes erupted with incredible force and meteorites bombarded the planet's surface. These violent events were both destructive and creative, contributing to the planet's evolving landscape. Yet, amidst this chaos, the stage was being set for the emergence of life. The very conditions that made early Earth so hostile were also the conditions that would eventually allow life to flourish. Around 4.5 billion years ago, a Mars-sized object collided with the young Earth in a cataclysmic event. This impact ejected a massive amount of debris into space, forming a ring around our planet. Over time, gravity pulled this debris together, eventually forming our moon. The moon's gravity stabilized the Earth's rotation, preventing drastic climate swings. It also created tides, which would later play a crucial role in the evolution of life. The moon stands as a silent witness to the Earth's early history. Its cratered surface bears the scars of countless impacts, a reminder of the violent events that shaped our solar system. As the Earth continued to cool, the constant rainfall eventually began to accumulate on the surface. Low-lying areas filled with water, forming the first oceans. These early oceans were likely shallow and acidic, but they were vast, covering much of the planet's surface. The appearance of liquid water was a pivotal moment in Earth's history. Water is essential for life as we know it, acting as a solvent for chemical reactions and a medium for transporting nutrients. The oceans provided a stable environment where life could emerge and flourish. The early oceans were also responsible for absorbing much of the carbon dioxide from the atmosphere. This helped to regulate Earth's temperature, making it more hospitable for life. The exact origins of life on Earth remain a mystery, but scientists believe that life arose in the early oceans around 3.5 to 4 billion years ago. These first life forms were simple, single-celled organisms similar to bacteria. These early life forms thrived in the nutrient-rich waters of the primordial oceans. They were able to harness energy from their environment either through chemical reactions or by absorbing sunlight. Over millions of years, these simple organisms evolved and diversified, eventually giving rise to all the plants and animals we see today. The emergence of life was a profound event, transforming the Earth from a barren rock into a living planet. For billions of years, single-celled organisms were the dominant form of life on Earth. Then, around 2.5 billion years ago, a remarkable event occurred, the evolution of photosynthesis. Photosynthetic organisms like cyanobacteria developed the ability to harness energy from sunlight and produce oxygen as a byproduct. This process had a profound impact on the Earth's atmosphere. Oxygen levels began to rise, eventually paving the way for the evolution of more complex life forms. With the increase in oxygen, new metabolic pathways became possible, allowing for the development of larger, more complex cells. This led to the emergence of multicellular organisms, a crucial step in the evolution of life. Section 7, a planetary transformation, the reign of plants and animals. The rise of multicellular organisms led to an explosion of life forms in the oceans. Plants evolved, colonizing the shallow waters and eventually spreading onto land. Animals soon followed, venturing out of the sea and adapting to life on dry land. Over millions of years, life continued to evolve and diversify, filling every niche on the planet. From the depths of the oceans to the highest mountains, life found a way to thrive. The Earth's atmosphere and climate continued to change as well, influenced by the activities of living organisms. Plants released oxygen into the atmosphere, while animals exhaled carbon dioxide, creating a delicate balance that sustained life. Section 8, the age of dinosaurs. Giants walk the Earth. Around 230 million years ago, dinosaurs emerged as the dominant land animals on Earth. These incredible creatures, ranging in size from small, bird-like dinosaurs to gigantic sauropods, ruled the planet for over 160 million years. The age of dinosaurs was a time of incredible biodiversity. Dinosaurs evolved into a wide variety of forms, each adapted to its own ecological niche. They roamed vast continents, leaving behind footprints and fossils that tell their story. The reign of the dinosaurs came to an abrupt end around 66 million years ago when a massive asteroid collided with Earth. The impact triggered widespread wildfires, tsunamis, and climate change, leading to the extinction of the dinosaurs and many other species. Section 9. The rise of mammals. A new era begins. In the aftermath of the dinosaur extinction, mammals, which had lived alongside the dinosaurs for millions of years, began to diversify and flourish. With the dinosaurs gone, new ecological niches opened up, allowing mammals to evolve and adapt. Over millions of years, mammals evolved into a wide variety of forms, from tiny shrews to massive whales. They colonized every corner of the globe, adapting to diverse habitats and lifestyles. The rise of mammals paved the way for the evolution of our own species, Homo sapiens. Humans emerged in Africa around 300,000 years ago and have since spread across the globe, becoming the dominant species on Earth. Section 10. A continuous transformation, Earth's ever-changing story. The Earth's journey from a fiery ball of molten rock to the vibrant planet we know today is a testament to the power of time and change. In its infancy, Earth was a hostile environment with volcanic eruptions and constant bombardment by asteroids shaping its surface. Over billions of years, our planet has undergone dramatic transformations, shaped by geological forces, cosmic events, and the evolution of life itself. From the formation of the first oceans to the rise of complex ecosystems, each era has left its mark on the planet's history. Today, Earth faces new challenges, many of them caused by human activities. The rapid industrialization and urbanization of the past few centuries have significantly altered the natural landscape. Climate change, pollution, and habitat destruction threaten the delicate balance of our planet's ecosystems. The burning of fossil fuels, deforestation, and widespread pollution have accelerated the pace of environmental degradation. As we look to the future, it is essential to remember the lessons of Earth's history. By studying past climate changes and mass extinctions, we can gain valuable insights into the potential consequences of our current actions. Our planet is a dynamic and interconnected system, and our actions have consequences. Every decision we make, from the energy we use to the products we consume, impacts the environment in ways we may not immediately see. By understanding the past, we can make informed decisions to protect the future of our planet and ensure that life continues to thrive for generations to come. Embracing sustainable practices and renewable energy sources can help mitigate the damage and pave the way for a healthier Earth.